Hello guys, today I'm just making a video on some basic insights on how to solve questions related to the topic is Simple Atomic Model. I know many of you guys have this topic coming up for your chemistry exam, so hopefully this video can help you all in order to solve these type of questions. By the way, time codes will be in the description box below so that you guys can skip to any questions you guys like. And if you guys want to change the quality settings of this video, you guys can do that in the YouTube settings in order to see the questions more clearly. And by the way, this PDF or this worksheet is taken from the site Physics and Math Tutor. It's a very good website that you guys can use to learn other subjects as well. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And yeah, let's begin with the video. Alright, so the first question states that the figure below shows magnesium burning in air. So you guys can see that there's a bit of magnesium burning in air. And if you look at the figure above, how can you tell that a chemical reaction is taking place? So we can see that there's some form of flame present in this kind of diagram. So you guys can say that there is a flame. There's a flame present. So that's going to be our answer for 1 mark. You guys can also mention that the energy was given out, that a new substance was formed, or you can mention that the magnesium turned into a white powder. That can also be fine in this type of questions. Now, next one is that you have to name the product from the reaction of magnesium in the figure. So the product of magnesium reacting with air, that is about oxygen. So you guys can say that magnesium reacts with oxygen. That's going to give us something about, like, let's say magnesium oxide. Okay, when a metal mixes with, let's say, reacts with oxygen, it becomes metal oxides. So you're going to say that it's going to become magnesium oxide. That's going to be your answer for about 1 mark. Alright, let's move on to the next question. It states that the magnesium needed heating before it will react. What conclusion can you draw from this? So it needed heating, so you can say that the reaction has a high activation energy. That's the only way that the reaction, basically, or the magnesium would need heating before it reacts. So because it has a high activation energy in order to break it down. Alright, so we can move on to the next question. Next question states that the sample of the product from the reaction in the figure above was added to water and was shaken. The universal indicator was added. The universal indicator turned blue. What is the pH value of the solution? Since it's blue, that means it's going to have a pH value of about 9. It's pretty close to what it is alkaline, pretty away from the acid part, but it's an alkaline solution, somewhat like that. So it's going to have a pH value of 9. Let's move on to the next question. Now, the next question is stating, why are nanoparticles effective in small quantities? They're effective in small quantities. This is one point that you guys have to remember, is because nanoparticles are like these really tiny particles, and then they have a huge surface area to volume ratio per particle. So you're going to mention that they have a high surface area to volume ratio. That's going to be your answer in this case, right? Okay, so let's move on to the next question. Is that you have to give one advantage of using nanoparticles in sunscreens is that I can mention that they are better coverage, or they are more protection from the sun's ultraviolet rays. So you can say that there's a better coverage. There's a better coverage since nanoparticles. You can mention the reason as well, in case if you want to score those full marks. Since nanoparticles have, let's say, since nanoparticles have high surface area to volume ratio. Surface area to volume ratio. SA just means surface area. Right, that's one good tip that you guys can write down. But do write down the full word just in case in order to score that marks. Alright, let's give now we have to give one disadvantage of using nanoparticles in sunscreens. People about nanoparticles, they are a new upcoming technology, in this case a new field of nanoscience. So the harmful effects to the environment, that's something that you guys can mention always, that there's harmful effects on the environment using let's say using nanoparticles. Or you guys can mention that there could be a person who uses nanoparticles in the screen could have a potential cell damage to the body. So that could not happen, but preferably don't use nanoparticles in these cases since they have some disadvantages like these. So there could be harmful effects on the environment or potential cell damage to the body. Alright. Now, a coarse particle has a diameter of about, let's say, 1 × 10⁻⁻⁶ meters. Nanoparticle has a diameter as well. Calculate how many times bigger the diameter of the coarse particle is than the diameter of the nanoparticle. So they're asking us how many times this is bigger Now, in order to do this, I think you have to, there's some form of division in this case. So you have 1.6 times 10 raised to the power minus 9 divided by 1 times 10 raised to the power minus 6. So you're going to have a value of about, let's say, so what you're going to do is you're going to divide the nanoparticle divided by the coarse particle. How many times bigger is the coarse particle than the diameter particles? So what we're going to do is you have 1.6 times 10 raised to the power 9 divided by 1 times 10 raised to the power minus 6. If we take it in that case, we would have approximately, let's say, a value of about, I'm going to change these settings on this case using the calculator just to check what's the decimal value. It's about, like, let's say 0.0016. But if you do it in this case, you would be getting some value like this. But if you divide using the other way, such as 1 times 10 raised to the power minus 6, so there's two different values that you guys could get while dividing it in terms of this kind of ratio. So what you're going to do is you're going to divide this correctly. So instead of dividing it and getting a decimal value, since they're asking us how many times bigger the diameter of the coarse particle is, you're going to have 1 times 10 raised to the power minus 6 divided by 1.6 times 10 raised to the power minus 9. Once you divide that, you should be getting a 625 as whole numbers. This is going to be 625 times bigger. This is going to be your answer for about 2 marks. Alright, let's move on to the next question. Next question states that the electronic structure of the atoms of 5 elements are shown in the figure below. The letters and not symbols of the elements. Alright, so you have to choose the elements to answer the question. Each element can be used once, more than once, or not at all. I'm going to use the periodic table to help you. Remember, guys, one tip is that in the IGCSE or GCSE exams, you guys could get this periodic table for exams, so you guys can take out information from the periodic table to help you out. Alright, so which element is hydrogen? We know that hydrogen has about an atomic structure of 1 and a relative atomic mass of 1 as well. And hydrogen would be element B, since it has 1 electron in its shell. So we're gonna take B. Which element is a halogen? We know halogen are group 7 elements, and they're non-metals again. So since they're group 7, they must have 7 electrons in their outermost shell. So guys can see that element D has 7 electrons. If you count 2, 4, 6, 7. So that's 7 electrons in their outermost shell. So that means element D is the most reasonable choice for it to be a halogen. I'm just going to write it down that this is a group 7 element. Alright, group 7 element, so it's going to be D. Let's move on to the next question. Now the next question states that which element is a metal in the same group of the periodic table as element A. So since element A has 1 electron in its outermost shell, element E also has 1 electron in its outermost shell. Now, if element B also has 1 electron in its outermost shell, why cannot it be part of these element A and E? The reason is because element B, or let's say hydrogen, is a non-metal, while element A and E are non-metals. Alright, so that's why you can't include hydrogen in the group 1 metal series. So element A and E are pretty close to each other because they have 1 electron in their outermost shell, if you guys observe the diagram. So you're going to say that element E is going to be your answer. Alright, so you have element E, you're going to tick that box down. Now, which element exists as single atoms? As single atoms, meaning that they have a, I'm going to write it down. What do they mean by single atoms? Is that they have a full outer shell. Tip here, guys, full outer shell of electrons. Outer shell of electrons. Let's just mention that. I'm just going to write that down properly. So they have a full outer shell of electrons. So let's see in the diagram above which one has a full outer shell of electrons. We can see that element C has a full outer shell of electrons. That's 1, 2, that's 4, 6, 8. So there's 8 in the second valence shell. So that proves that element C is going to exist as a single atom. So we're going to tick C as well. So answers are going to be it's going to be, let's say, B, D, E, and C. Let's move on to the next question. Now the next question states that there are 2 isotopes of the element A. As you guys can see, I think we have done this in the previous questions as well. calculate the relative atomic mass. Now there's a nice little formula where AR represents relative atomic mass, which is equivalent to the sum of brackets isotope abundance times the isotope mass numbers. Okay, this is all going to be put in brackets. It's all going to be divided by the sum of abundances. You guys have to use this formula when dealing with isotopes. Sum of abundances of all the isotopes. Alright, so now what do I mean by this is we're going to multiply these two together and we're going to add them up with the multiplication of these two values. Alright, so I'm going to show you that in the equation here. So the relative atomic mass is going to be equivalent. This is a symbol for relative atomic mass. It's going to be equivalent to the sum of isotope abundance. That's 92.5 times 6. We're going to take this not as a percentage but as an integer, or let's say as a decimal value only, like a number itself. I'm going to add it with the multiplication of these two. That's going to be about 7.5 times 7 and divided by the sum of abundances of all isotopes. So what do they mean by this is that we have to add these two values together. Now when you add these two values, you should get a value of approximate to 100, because 92.5 plus 7.5, if you add them up, is that they become 100. So that's going to be your value. Usually it would be 100 below, so you guys can leave it as that. Once you do that, you have AR is going to be equivalent to, if you put it in brackets, guys, use a calculator. It's really helpful when dealing with chemistry as well. Even with physics, just use a calculator. So divided by 100. Once you do that, you should be getting a value of about 6.075 is equivalent. We have to convert it to 2 decimal places. Once you do that, you have 6.08. This is going to be our answer. Now relative atomic mass has no units, so that's another tip there. So you're going to leave it as 6.08 by let's say converting it to about 2 decimal places. Alright, so that's going to be our answer for 4 marks. Let's move on to the next question. Now the next question states that I'm just going to show you guys if you guys want to take any notes in this case. Alright, let's move on to the next question. Now this question is about mixtures and analysis. Which two substances are mixtures? We know that air is a mixture since it contains a lot of elements in air itself, and we know that steel is a mixture as well. It's considered an alloy. Alloys are just mixtures of metal. Alright, let's move on to the next question. Now draw one line from context to the correct meaning. So you guys can see that a pure substance in chemistry refers to a single element or a single compound. Get the definition right. Now a pure substance in everyday life is about, I'm going to just draw an arrow there. Pure substance in everyday life is just a substance that has nothing added to it. So pure substance chemistry is a single element or a single compound, and a pure substance in everyday life is a substance that has nothing added to it. Okay, let's move on to the next question. Next question, what is the test for chlorine gas? This is now more related to content learning. You guys are going to write down, you guys are going to tick the option that damp litmus paper turns white. So you're going to tick that box as well. Alright, okay, let's move on. Next question. Now the next question says that a student tested a metal chloride solution with sodium hydroxide solution. A brown precipitate was formed. What was the metal ion in the metal chloride solution? So since it was a brown precipitate, we know that's going to be iron 3. So you're going to tick that option of iron 3. It's going to be for 1 mark. Alright, let's move on to the next question. Now the next question states that, now you guys can see a nice little diagram showing you copper, silver, and gold. Alright, so you guys can see that there's copper, silver, and gold is mixed with other metals to make jewelry. So the figure below shows the composition of different carat values of gold. Alright, what's the percentage of gold in a 12 karat gold? So in a 12 karat gold, what is the percentage? So this is more like an analysis question, and if you carefully look, you guys can see the carat value of gold, and it's going to be roughly about, let's say, if this is about 18 carats and this is 9 carats, somewhat about 50% is going to be your percentage of gold in a 12 karat gold. That's going to be roughly about that. You guys can check that gold here is approximately, let's say, if you divide each square by 5, 10 divided by 5, that should be giving a value of about 2. So you have approximately 74 minus, let's say, 32, 34, 36, roughly about some 50. That's going to be your 12 karat gold composition. Alright, let's move on to the next question. Now, give the percentage of silver in a 18 karat gold. Now, we know that silver metal here is Ag, so it's going to be the percentage, if you guys look carefully, that 10 divided by 5, that's going to be 2% per silver, sorry guys. So this is going to be about 80% minus, let's say, somewhere in between 72, 74, 74 and 76, so that's going to be 75%. So 80% minus 75%, that's going to be about 5% is the composition of silver. Alright, so that's going to be 5% composition of silver. That's going to be your answer. Alright, let's move on to the next question. So there's 2 reasons why 9 karat gold is often used instead of pure gold to make jewelry. Now, 9 karat gold is because it's a mixture of metals. Like I said, pure substances are usually soft. So you can say that pure gold is soft. And you can also mention that 9 karat gold is harder. That could be answered. You guys can also mention that, and depending on the cost, that 9 karat is cheaper, and that 24 karat gold is also soft as well. You can also mention that gold is an alloy in 9 karat gold, and you can say that it can change color as well. Alright, let's move on to the next question. Or you could just mention that pure gold is soft and 9 karat gold is harder. Okay, now the next question states that this question is about hydrocarbons, so it's pretty related to the organic chemistry side, so you guys have to know that. What is the formula for pentene? Pentene has a value of about 5 in the carbon atoms, so since it's going to have a value of 5, so you're going to use that formula CH, I think it's about, let me just, CnH2n plus 2. I think this is a formula for, let's say, for the homologous series. So you have carbons about 5, so you have H 2 times 5 is 10 plus 2, C5H12, so that's going to be C5H12. Now this is going to be your formula for pentene because it's part of the homologous series. Okay, it's an alkene, I think, something really alkane. Yeah, because it's ethane, so these are alkanes. Alright, so C5H12. Now, which homologous series contains ethane, propane, and butane? This is going to be alkanes, so you're going to take that option. Let's move on to the next question. Is that propane, C3H8 is used as fuel. You're going to complete the combustion of propane. So what you're going to have is, since you have something about an alkane plus oxygen, you're going to get a carbon dioxide, right? So you have CO2 and carbon dioxide, is going to be 3 CO2, and you have 4 H2. You're going to get carbon dioxide and water. That's going to be your answer for that type of formula questions, alright? Alright, so you have 3 CO2 and 4 H2O. Alright, let's move on to the next question. Octane is a hydrocarbon that is found in petrol. Explain why octane is a hydrocarbon. The definition is because that it contains octane contains hydrogen and carbon only. Now, here are some useful tips here. When dealing with hydrocarbons, you guys have to remember that hydrocarbons are only made up of hydrogen and carbon, and you have to mention this word only. So it's really critical that you guys mention that word. So octane contains hydrogen and carbon only. Okay, that's going to be your statement for about 2 marks. Alright, okay, now the table below gives information about the pollutants produced by cars using diesel or petrol as fuel. We're given a nice little table here, so we have to analyze this. Compare the pollutants from cars using diesel with those cars using petrol. Since we have to explain for 3 marks, you guys can say that diesel, if you guys noticed, is that the oxides of nitrogen, 31 is greater than 23. So you can say that diesel produces more oxides of, let's say, nitrogen. More oxides of nitrogen. That's 1 point. You can also mention that diesel produces like more particulate matter than petrol. You guys can see petrol has about 0 particulate matter. So you guys can write that diesel produces, let's say, more particulate matter than petrol. That's something that you guys can mention as well. I'm going to reload the system again. Then you guys can also mention that diesel produces less carbon dioxide than petrol. That diesel produces less carbon dioxide, CO2. I'm just going to write CO2 just for now. Less carbon dioxide than petrol. So this is going to be your 3 statements: that diesel produces more oxides of nitrogen than petrol, that diesel produces more particulate matter than petrol, and that diesel produces less carbon dioxide than petrol. CO2, just write down the full statement, carbon dioxide, just for 3 marks. Alright, let's move on to the next question. Pollutants cause environmental impacts. You have to draw 1 line from each pollutant to the environmental impact caused by the pollutant. You guys can see that oxides of nitrogen causes acid rain, particulate matter causes global dimming. Now these are going to be 2 points, 2 lines for 2 marks. Alright, let's move on to the next question. Now the next question, this question is about carbon gases in the air. So carbon atoms have protons, neutrons, and electrons. Compare the table by writing down the relative mass of a neutron and electron. You know the neutron has a relative mass of about 1 as well. You know that electrons are very small stuff, so you're just going to write very small, or you can mention that something about 0 or 1 divided by 2000. That's also fine as well, or 0 point some certain value. So it's very small, 1, very small. What's the total number of protons and neutrons in an atom called? This is called the mass number, so you're going to take that option. Okay, an atom of carbon has 6 electrons. Which structure, A, B, or C, represents the electronic structure of the carbon atom? Of the carbon atom, we know that if you guys look in the periodic table, is then the carbon atom has 2 electrons. Alright, so you have about 2, 6. So this is kind of correct. So it's going to be structure C, since the atomic structure of carbon is 6. I think, yeah, roughly about that. So it's going to be structure C. Okay, you guys can check in the periodic table just to confirm that value. Now, carbon reacts with oxygen to produce carbon dioxide. How many different elements are in 1 molecule of carbon dioxide? So there are roughly about 2 molecules in present. Now what's the total number of atoms? Since we know that carbon has about 1 atom, oxygen has 2, you're going to add 1 plus 2 is going to be 3. So there's 3 number of atoms in 1 molecule of carbon dioxide. Let's move on to the next question. Now this question is about relative formula mass. You're given that sometimes carbon reacts with oxygen produce carbon monoxide. You have to calculate the relative formula mass of carbon monoxide. Since there's only like 1 atom of carbon and 1 atom of oxygen, what you're going to do is you're going to add up the relative atomic mass of these individuals. You have 12 plus 16 to give you a value of about 28. So it's going to be 28. That's going to be your MR of carbon monoxide, which is going to be the relative formula mass of carbon monoxide to be roughly about 28. Alright, let's move on to the next question. Now the next question is that we have to calculate the percentage by mass of carbon and carbon monoxide. Now, in order to calculate this, I know that there's a pretty nice formula that you guys can use. Is that you have to find the percentage mass of an element. Is that in order to do that, I think there's a formula. I'm trying to recall that kind of formula. I've seen it somewhere in the questions below previously. It comes under, I think it comes in quantitative chemistry. So when dealing with percentage by mass, you have to know your relative formula mass as well in this case. So it's very critical that you guys know the relative formula mass for this type of question. So the nice little formula that you guys can use is that the percentage mass of element is going to be equivalent to AR relative atomic mass times the number of atoms divided by the MR of the compound. MR of the compound is going to be multiplied by, let's say, 100 to give it into a percentage. So since you know that the percentage mass is going to be equivalent to the AR, so the AR here in this case is going to be let's say the AR of carbon, as the relative atomic mass of carbon. So it's going to be 6 times number of atoms of carbon, that's only 1, divided by the MR of the compound, it's going to be 28, times 100, that's going to be equivalent to 6 times 1 divided by 28 times 100. That's going to give you a value of about, let's say, this is E1, right? So you guys can see this is carbon monoxide. So since this is E1 is going to be 28, this should be, actually this value is not correct actually. It should be roughly about 42.9. So I'm going to use the periodic table, guys. Let me just hold up for a moment. I'm going to check what's the relative atomic mass of carbon. So the relative atomic mass of carbon is roughly about 12. So if you replace 6 with 12, now if you multiply 12 times 1 divided by 28 times 100, that should give you, now this should give you a correct value of about 42.85. Okay, so the relative atomic mass of carbon is 12. Okay, just to confirm that part, so it's 12 times 1 divided by 28 times 100. It's going to be equivalent to 42.85 percentage. If you guys want to round it off, you guys can do that to about 1 decimal place. You have 42.9%. This is going to be your answer. We're going to write here down 42.9 percentage. That is going to be your answer, 42.9%. Okay, let's move on to the next question. Now the next question, you guys can see there's a little nice diagram of a graph. So what's the percentage of argon in the air? So the percentage is roughly about 0.9. As you guys can see, it's between 1.0 and 0.8. So it's going to be about 0.9. That's going to be a rough analysis guess. An instrumental method is used to measure the amount of carbon dioxide in the air. Give one reason for using an instrumental method. You can just mention the word. Since it's 1 mark, you can say that it is accurate. That's more than enough. You guys can also say that it is sensitive, or it's rapid, or it's basically like a small sample, but mainly just say it is accurate. That's it. Now, or you can mention that the instrumental method is accurate. Let's move on to the next question. Now the next question shows us a carbon atom. So you guys we have to see that, we have to label it. So you have neutrons here, as you guys know. Then you have electrons, which have a negative charge. Neutrons have neutral charge. Protons are being positive, so you have neutrons and electrons. Alright, now proton is labeled. Use the correct answer from each box. Okay, this refers to labeling the diagram. The amount of carbon is represented as that. What is the mass number of this carbon atom? The mass number of this carbon atom is going to be 13. Alright, since it's on the top, it's going to be 13. Complete the sentence. Atoms of carbon have no overall electric charge because the number of protons is the same as the number of electrons. This is going to be your answer for about 1 mark. Okay, let's move on to the next question. The next question states that butane is it should be a compound. Butane is a compound. Butane contains atoms of carbon and hydrogen, and that each line between the atoms in butane represents a chemical. It's going to be a bond. Alright, so I'm going to read this again. Is that butane is a compound. Butane contains atoms of carbon and hydrogen, and each line between the atoms in butane represents a chemical bond. Alright, let's move on to the next question. Now the next question is, which is the correct formula for butane? If you guys can see clearly that there are 4 carbon atoms, so since there are 4 carbon atoms, and let's see how many bonds of H there are. Since it's a butane, 4 carbon atoms, so you're going to use that formula, CH2N plus 2, which is going to be C4H2 4 plus 2, 2 for 6A plus 2, H, that's going to be 10. So it's going to be C4H10. This is going to be a calculation. This is for an alkane formula, so do check out organic chemistry as well, alright? So you have C4H10, that's going to be a value, so this is C4H10 just like we calculated. So that's C4H10 just like the value we calculated from above, C4H10. Alright, so this seems to be the end of all the questions. If you guys have enjoyed the video, please do like, share, and subscribe to the channel. It really helps a lot. And do comment below on what your thoughts are about this video, and whether I should continue solving past paper questions or topic by wise questions. Do do check out the other videos, which is going to appear on the screen right now. And I think that's it, guys. Yeah, do stay motivated, and yeah, that's it. Bye, guys.